Question number 5 from section 3.2. What we want to do in this section, we want to solve this differential equation using the method of reduction of order. And the way this method works, we want to substitute for y and write y in terms of v. And the problem has given you what y1 should be. So, and it also tells you to start with y2 of x is equal to v of x times y1 of x, and y1 is given to you. So what we have to do is find the first and second derivative, and then we are going to substitute for y double prime and y prime and y in terms of the new equations that we get. So I have to find, I'm going to call y2 just y, and then I'm going to drop all the x's, so it's neater. So I have v, and instead of y1, I'm going to put x to the power 2. So that is going to be our y. So I'm going to change that y to vx to the power 2. But I also need to find y prime. To find y prime, we have to do a product rule. So this y prime is d by dx. So to find d by dx, we have to do the product rule here. We find derivative of v with respect to x. Instead of writing it dv dx, I'm just going to call it v prime times x to the power 2. Derivative of x to the power 2 is 2x times v. Done. Then we are going to find y double prime. To find y double prime, we are going to do another product rule. Derivative of v prime is going to be v double prime times x to the power 2. Plus derivative of x to the power 2 is 2x times v prime. We are going to do another product rule here. Derivative of 2x is just 2 times v. Derivative of v is v prime times 2x. I want to write this as also x squared v double prime, just switch them around. And the same here, I want to write it as x to the power 2 v prime, just to be more organized. So now all these have to be substituted in this equation. In this equation, we have the value for y prime, and y double prime. As you see here, we have x to the power 2, so I'm going to multiply this one by x to the power 2. This one is being multiplied by x, and that one is being multiplied by -4, and then we are going to add them. So let me just put a -4 here. I'm going to multiply x. This becomes x to the power 3. This becomes 2x to the power 2. If I multiply this one by x to the power 2, I get x to the power 4. This becomes 3. This becomes 2x to the power 2. And this one is going to be 2 more. So now let's add them, right? So let's look for like terms. This one doesn't have any like terms, so we leave it as x to the power 4 v double. Then I have 2x cubed and 1x cubed, and another 2x cubed here, that they all have v prime and x cubed, they're like terms. So I have 1, 2, and 2, that gives me 5. Then I have 2x to the power 2 minus 4x to the power 2v. So this is minus 4x to the power minus 4x to the power 2v. I have another one here. So 2 and 2 is 4, and negative 4. They're all going to cancel each other. I get 0 of those, and that's it. And that whole thing is equal to 0. So I just added all these together, substitute them, and then added all the 3 lines, and this is what we get. So all I have to do is now solve this differential equation. So I'm going to separate the variables. I have v double prime, subtract this from both sides. Divide both sides by x to the power 4. These 3 x's with that one, they cancel each other. Divide by v prime. So I get v double prime over v prime is equal to minus 5x. Now, if I want to find the integral of this side and this side, so just think of it like that. That's what I'm trying to do. Because of the double prime, I'm just going to do a little substitution so you see what's going on. I'm just going to call u v prime. Therefore, du dx is going to be v double prime. So I am going to call v prime u, and I'm going to call v double prime du dx. You don't have to do this if you can see easily that integral of that is just going to be natural log of v, and integral of this side is going to be negative 5 natural log of x. You can just jump into it, but if you don't see what's happening, I think this is easier for you to see that this is going to be natural log of v prime, and this side is just going to be negative 5 natural log of x plus c. You can just do that, or I'm going slowly here. I'm using this kind of substitution. So then I'm going to multiply both sides by dx. I get du over u is equal to negative 5x dx. Then I will find the integral of both sides, and that gives me natural log of u is equal to minus 5 natural log of x plus c. And I'm going to call c natural log of c. I'm going to move this here. So I get natural log of u is equal to natural log of x. And since x is greater than 0, I really don't need this absolute value, because somewhere up there it told you c, all the c's are bigger than 0. So then these two join. I can write that as natural log of u. Since everything is greater than 0, I drop the absolute values. That's what I have. I use the property here, made that an exponent. I use the log property here to write this as natural log of c times x minus 5. Then I drop the logs. I get u is equal to cx to the power minus 5. But remember, u is v prime. So this is our dv dx. Now, instead of u, I'm going to call it dv dx. We are going to find the integral of both sides one more time. So dv cx minus 5 dx. So I get v is equal to, add 1 to the exponent. So it becomes x to the power minus 4 divided by minus 4. plus some constant, let's say a. Then I'm going to A and C are constant, they could be anything. So for instance, I let C to be -4 and I let A to be 0. So that's a possibility. So that's what you have to do for these problems. You always make your C to be this denominator and make A equal to 0. So then you get V is equal to this -4 and -4 cancel each other, and that's a 0, so you get 1 over x to the power 4. That's your V, right? But the question was, what is y2? y2 of x is equal to V of x times y1, and y1 was x to the power 2. So x to the power 2 and x to the power 4 are reduced. You say y2 of x is equal to 1 over x to the power 2. And that is what they were looking for. That was the answer they were looking for.